Hi everyone, today we're going to study root tests. Let summation of a sub n be a series with a sub n greater than or equal to 0 for small n is greater than or equal to big N. And suppose that the limit as n approaches infinity of the nth root of a sub n equal to a value rho. This is now the test of convergence. The series converges if the rho is less than 1. The series diverges if rho is greater than 1, while the test fails if the rho is equal to 1. Example 1. Check the convergence of the series using root tests. Summation from n equals 1 up to infinity. In the numerator, we have ln that is raised to power n all over n raised to n. First, let us collect the a sub n. Take note here that we can simplify this expression into ln over n that is raised to power n. Now, by root test, we write the limit as n approaches infinity of the nth root of a sub n. First, let us simplify this expression, the nth root of a sub n. Let us substitute the corresponding value. So we have now the nth root of ln over n, and the fraction is raised to power n. We can see here that the index of the radical is the same with the exponent n. So we can cancel the radical and the exponent n. And this will now be simplified into ln of n all over n. This value is what we're going to use in here. So the root test limit will now becomes limit as n approaches infinity of the expression ln of n all over n. Take note here that when we evaluate the limit, our expression here becomes infinity over infinity, and that becomes an indeterminate form. So for this problem, we're going to apply the L'Hopital's rule. It means we will take the derivative of ln n over the derivative of the denominator n. So we have now the limit as n approaches infinity of, in the numerator, is the derivative of ln of n, which is 1 over n, all over derivative of n, and that is 1. Then let us evaluate the limit as n approaches infinity. In the numerator, the 1 over n will come to 0 over the constant 1. And the 0 over 1 is simply 0. Now, let us recall the test of convergence. We can see here that the value is 0 and this is less than 1, which means the series converges. Example 2. Check the convergence of the series using root tests. Summation from n equals 1 up to infinity of the quantity 1 over n minus 1 over n squared, and the difference is raised to power n. Our a sub n is the 1 over n minus 1 over n squared, and the quantity is raised to power n. By root test, we write the limit as n approaches infinity of the nth root of a sub n. Let us simplify this nth root of a sub n on the side. Substituting the value, we have now the nth root of 1 over n minus 1 over n squared, and the quantity is raised to power n. We can see here that we can simplify this because the index of the radical is the same with the exponent n. So this expression will be simplified into 1 over n minus 1 over n squared. And this expression is what we're going to use as substitute in here. So we have now the limit as n approaches infinity of the expression 1 over n minus 1 over n squared. Evaluating the limit, we have now 1 over infinity minus 1 over infinity squared. We know that this will be equal to 0 minus 0, which is 0. Now, our test of convergence is here. Our derived value is 0 and this is less than 1, which means we conclude that the series converges. I hope you learned something from this video. See you again next time.